Hello everyone. This session is focused on hardware synchronization to solve the critical session problem. So let's have a base on what we have studied in the last session video. Now solution to critical session problem can be ranging from software to hardware application for program interface. The software solution what we saw was Peterson's solution in the previous video. You can refer the previous video to understand Peterson's solutions in a better way. The limitation to Peterson's solution was it is applicable only to maximum 2 processes. That was the first drawback, and it is not adaptable to the modern computer architecture. So we don't know whether it will work in the modern computer architecture. That was a restriction to the Peterson solution. So if you think about the hardware solution, one of the solution is disable interrupts. If you think about a uniprocessor system, where if I think about one processor who is trying to access the critical session, then I know that the other process will access the critical session only if process P1 completes its entire execution. That is what uniprocessor. One process is executed, then only the next process executed. So there is no chance of a race condition existing in a uniprocessor system. But in a multiprocessor system, so what we do in a uniprocessor system is we disable the interrupts when a particular process is executing its critical session part or shared variable part. But in a multiprocessor system, if a particular process is accessing the critical session, other processes who are trying to run parallelly, I have to send a message to all other processes saying that I am performing the critical session, you all disable the interrupt. So this message passing takes a lot of time. So message has to be reached to the other process to disable its interrupt. They are not raising any interrupt, so that P1 is not getting preempted, and the entry to critical session thus delays, because message has to be reached, the acknowledgement has to come, and then only P1 can enter into the critical session. As well as when a P1 is executing the critical session, I am disabling all the interrupts including the system interrupts. The updation of time etc. will be affected. So I cannot go for a solution where I am going to disable interrupts in a multiprocessor system. That is not at all a feasible solution. So we will go for hardware synchronization method, where we use a special hardware instruction. There are two special hardware instruction what we use. The first one is test and set. That means it tests and then modify a content of a word. And another particular hardware instruction is swap, that is swap the contents of two words. The feature of this particular instruction is it performs atomically. It acts as an, or it is executed as an one uninterruptible unit. It performs as one uninterruptible unit. This is the main feature of this particular hardware instruction. So let's see how the test and set is being executed. In test and set, we have the definition of test and set function as Boolean test and set target. So we initialize a target which is pointer to a memory address. So let it be a target over here, and it is a Boolean function. So target can have only two values, either true or false, one of the value. And I initialize a return value register, so RV, which is also a Boolean function, and it also can be either true or false. Now this is the definition of Boolean function. I have just numbered over here, I will come to it later. Now Boolean RV is equal to pointer target. So let's start from over here by initializing my target is equal to false. So here it is false, and here I'll just assume RV is equal to true. Any condition can be taken, or let me assume both are false as the first case which I have taken over here. Boolean RV is equal to pointer target. Whatever the value is in the target, it is transferred to RV. So RV now will be having false. That means this will be transferred over here, and the second line, that is the first line, the second line says that pointer target is set to true. So this will be set to true. So what happens? Initially both were false. After the execution of line number 1, RV is set to false and target will be set to true. And third line say return the value of RV. What is the value of RV after the target value has been pushed into RV? It is false. So the outcome is false. The second condition is this is true and RV is true and target is false. So here this is false and this is true. After the line number 1, RV has the value of target. So target is false. So RV becomes false. And target is set to true. The second line is target is always set to true. So this becomes true. And return the value of RV. RV is false. So this becomes false. The third case is RV is false and target is true. The first line says that Boolean RV is equal to target. So RV is getting the value of target. So it is true and target is set to true in the second line over here. So this becomes here true and false, true and true, and the return value is true. So it is true. The line number 3 ends up with the true value. And the fourth is true and true. So here both are true. So RV will get the value true after the first line and second line sets the target and return value of RV is true. So the outcome is true. So this is what we have, the 4 cases what I have taken over here. Anyhow, after the line number 2, you can see that always the target are set to true. So according to the definition, the return value of RV is used to test and set condition. So I have written over here, if the initial value of target is false, the return value also will be false. If the target is initially is true, this is going to be true. So from here you can see that initial value of target, if it's false, the outcome is false. Here also false, here also false. When it's true, here true, here true. So this is a base concept what we are going to use in the implementation part. In the implementation part, a process has to execute the following code. Any process who want to go for the accessing the critical session has to access this particular code. First it runs a code, that is, I can use here line number 1 saying that while test and set and lock. So whenever I call test and set and lock, it will call this particular function Boolean test and set and pointer target. That means the lock is nothing but the target value. So I'll replace the target with lock. Okay, and Boolean RV is pointer target. So whatever changes we have in the target value, it will be reflected on the lock. It is passing by reference function. So whenever I am calling and lock, it will call this particular function and the modification made in the target will be reflected onto the lock. So if you remember in the previous session, whenever a particular process want to enter into the critical session, it has to run an entry section code to acquire lock, and once it gets the lock, it enter into the critical session, and once it finish, it has to run the exit session code to release the lock. So this was a basic concept what we have seen from the beginning of process synchronization. So it is release lock. So in this particular code, whenever a process want to enter into the critical session, this becomes the entry section code, this part, and this becomes the exit section code. So let's see the implementation. So as I said, and lock is here over the target values. In critical section problem, we are going to check 3 conditions. The first requirement is mutual exclusion. The second is progress, and third is waiting, bounded waiting. You can refer the previous videos for the basics of critical section problem and process synchronization. So let me assume there are 2 process P1 and P2 who are competing for critical session, and first P1 try to enter into the critical session. So I'll just make a tabular column with the updation of lock value. So lock is a global variable. So I'll show over here. Lock is a global variable. So whatever the value of lock, P1 and P2 can see those value. Let me initialize the lock value as false. So in the first condition, lock is set to false. P1 tried to enter into the critical session. So while test and set and lock. So lock is initialized to false. So when this is run, the code while test and set and target, we see that the return value is going to be false. So the while condition is false over here and P1 enter into the critical session. I'll repeat. Whenever a particular process try to enter into the critical session, suppose P1 is trying to enter, it run this particular code while test and set and lock. Lock value is false. If lock value is false, the return value will be false. So after running the while test and set, the return value will be false. Thus it enter into the critical session. If it was true, it would be looping over here itself. Now the condition is false, so it enters into the critical session. So P1 after, let me name this as line number 1. Critical section is a big code, but I'll say it as step number 2. This is step number 3 and let it be step number 4. So P1 ran the line number 1 or step number 1. The condition become false and it enter into the critical session. Now, according to the requirement, mutual exclusion should be maintained. That means when P1 has entered into the critical session, P2 should not be allowed to enter into the critical session. Now, after entering the critical session, I have one more condition, that is in our while and test target, after entering, the return value will be false, but the lock value will be set to true. Remember, after doing it, lock will be set to true. So here, the lock will be set to true. If you see the definition of critical session using test and set, I said the target will be set to true in the line number 2. So here in second over here, this becomes true, and now P2 is trying to enter into the critical session. As a definition or as a requirement, P2 should not be allowed to enter into the critical session because P1 is executing the critical session. Let's see, if P2 tries, it has to run this while test and set lock. What is the lock value right now? True. So it will return the value true. So this condition becomes true and P2 will be blocked here itself without allowing to enter into the critical session. So P2, it runs the first step, that is while condition, and return value will be equal to true, hence it will be blocked from entering into the critical session. So what we have seen in here, when P1 is accessing the critical session, P2 is blocked from the entry of critical section. So thus mutual exclusion is maintained. Now when can it enter? When P1 finishes the critical session. When P1 finishes the critical session, the lock is set to false. So here, third, when P1 finishes critical session, so let me say it finishes critical session, lock is set to false. When lock is set to false, what happens? Now here P2 is going on trying, so here also P2 will be checking in the while condition, test and set lock, lock is false, then my return value will be false, then it enter into the critical session. And after entering into the critical session, before entering into the critical session, it will obviously set the lock to true, so lock is equal to true. This would have entered its remainder section. When this finishes the critical session, this would have entered into the remainder section. So we can see here, when P1 finishes the critical session, it is not blocking P2 to enter into the critical session, and the maintenance of mutual exclusion is there. And now let me say, when this entered into the critical session, you can try yourself. P3 is trying to enter into the critical session. Now what is the current value of lock? The current value of lock is true. When P3 tries, it sees this while condition becomes true and the return value is true, and P3 will be looping here itself without having the access to critical session. So again, P3 cannot enter when P2 is accessing a critical session. So again, the mutual exclusion is maintained. So the first condition or the first requirement using the test and lock is satisfied. The second condition is, or second requirement is progress. We will check whether the second requirement progress is being satisfied. So in a critical session problem solution using test and set, it is two things. That is, whenever it performs test and set, we have the initial value of lock is equal to false. So when it perform test and set, so initial value of lock, it will be testing. What is the initial value of lock? This value will be returned. So return variable will give me the value false, and the lock will be set to true. Lock will be set to true. Remember, whenever we function with the test and set, it does two things. First, it checks the value of the lock, which is returned for the while condition, and if the while condition is false, then it enter into the critical session, and the lock will be set to true at the same time. So let's check for the progress. Now process P1 enters into the critical session by checking the condition while test and set. Since the lock is false, it sets first, it checks the value of lock, which is false, then it set lock is equal to true. So here it is set to true, and then it enter into the critical session. Now after performing the critical session, it perform lock is equal to false. So again lock is set to false. So this becomes false, and then it goes to the remainder section. Now when it is performing remainder session, or I can say it is just going to the sleep later. That means it doesn't further want to participate in the critical session. At the same time, P2 was waiting to enter into the critical session when P1 was performing the critical session, where it was blocked to enter into the critical session because of the mutual exclusion property. So when P1 comes to the remainder section and sleep, the lock is set to false. P2 go with the while test and set lock. Lock is false, and it set the lock is equal to true, and then it enter into the critical session. After coming from a critical session, lock is again set to false, then it goes to the remainder session. But when it reaches the remainder session, it says that I want to enter once more into the critical session. Whether it can do so? It can do so because lock is already set to false, and it can come back again. It does the same procedure, setting the lock is equal to true, testing the value of lock, the condition becomes false, it again enter into the critical session, again it does the same thing, again it come to the remainder session, again it want to participate, where P1 is not blocking P2 to enter into the critical session multiple times. Or let me say, when P2 finishes, P3 is trying to enter into the critical session. That also can happen, because when P1 exit, P2 exit from the critical session, it set the lock is equal to false. So when P3 tries for the while condition, it tests the lock is equal to false, set the lock is equal to true as the same over here, enter the critical session, and continues with the same procedure, where P1 was not blocking other process to enter into the critical session. It does mean that if any particular process who want to compete for the critical session only will be participating to enter into the critical session. P1 was sleeping, it was not, although it had a critical session, it was not participating in the competition of critical session. That does mean the progress. So the second condition is also satisfied, and the last requirement is bounded waiting. Let us check whether the bounded waiting condition is met. In bounded waiting condition, P1, it checks the lock is equal to false, set the lock is equal to true, so it becomes true over here, enter into the critical session, then lock is equal to false as over here, that is false over here, come to the remainder session, and then try to exit. So when this is performing the critical session, let me say P2 wanted to enter into the critical session, but when P1 reaches the remainder session, it says that it want to again participate into the critical session. Can it do so? Yes, because here whenever it is checking for the second time, this was the first time, second time when it is checking, it checks whether the lock is false. Yes, lock is false, set it to true, go for the critical session. P1 will be waiting for the first time. Now third time also P1 tries, and let me assume P1 is having a priority than P2, so P1 enters again, so this is waiting for the second time also. Now again fourth time this enters, this is waiting for the third time, so this is entering for the fifth time, this is waiting for the fourth time. There is no bounded time limit where P2 is waiting to enter into the critical session. So as many times P1 want to enter, it can enter and do so, because lock is set false by P1 itself, and P1 is repeatedly participating and entering into the critical session, and P2 is without a bound limit of waiting. It is going on waiting, which is nothing but a starvation problem. So the bounded condition over here is not met, or it is not able to satisfy the bounded waiting, but it can be a good solution for the critical session problem. Still it has some drawbacks, like application programmer doesn't find it easy to apply this hardware synchronization tool for critical session problem. In the upcoming videos, we are going to see hardware based synchronization using the swap function, and later we will see the classic synchronization problem and how we are going to solve those problems using semaphore.